Welcome to This Explainer. Today, we're diving into a genuinely fascinating architectural story from Aaron Rose about breaking straight through the browser's storage limits. We're talking about handling massive, truly massive data sets entirely client-side. If you build heavy, data-intensive web apps, you're definitely going to want to stick around for this one. So let's just jump right in. We start our story with a junior developer named Timothy, who found himself staring at this. Yeah, that dreaded red console error that completely tanks your application. Quota exceeded. Honestly, if you spend any time at all working with client-side storage, you know exactly what that pit in your stomach feels like. It just brings everything to a grinding halt. But what was Timothy actually doing to trigger this? Well, he'd built this gorgeous, robust streaming ND-JSON engine, and it was smoothly handling 100,000 diagnostic records right over the network. The data flow, absolutely flawless. But there was a massive catch. The second a user reloaded the page, boom, all 100,000 of those records had to be fetched all over again. That's just a huge waste of network resources, server compute, and frankly, it makes for a terrible user experience. Which brings us to Section 1, the 5 megabyte wall. To fix that network inefficiency, Timothy tried caching that parsed log array using standard browser tools like local storage, but his application catastrophically crashed the literal exact moment his dataset crossed the 5 megabyte mark. 5 megabytes. Think about it. In today's web, where we're slinging around high-res assets and giant data grids, 5 megabytes is basically nothing. Section 2, the string trap. Enter Margaret. She's Timothy's senior colleague at their Victorian library office, a place where code craftsmanship is a really big deal. She takes one look at his failing code and immediately spots the bottleneck. Okay, step 1, Timothy has this highly optimized asynchronous data stream. Awesome. But then step 2, he forces that entire massive array of JavaScript objects through JSON stringify. He's freezing it into one gigantic string. And because of how local storage works under the hood, step 3 is the real killer. It completely blocks the main UI thread. He literally took something fast and fluid and turned it into a synchronous brick wall. And then Margaret delivers this absolute reality check. She says, "You are treating the browser like a basic cookie jar when you should be treating it like a production database server." Man, I love that. It so perfectly captures the trap we all fall into. Local storage is great for, a Dart mode toggle or a simple user ID, but a massive diagnostic log? No way. It just wasn't built for that. So, moving on to Section 3, enter IndexedDB. If we actually want gigabytes of data to survive a page refresh without destroying our app's performance, what do we do? Margaret steps up to the whiteboard and writes out the solution, IndexedDB. It's a fully asynchronous, transactional, object-oriented database that already lives right inside the browser. And here's the best part. It stores raw JavaScript objects natively. It doesn't care about strings. You literally never have to force your elegant objects through JSON stringify ever again. Look at this comparison. The case for IndexedDB is just rock solid. Local storage is stuck with that tiny 5 megabyte limit, it blocks your code execution, and it relies entirely on strings. But IndexedDB, it swaps that out for incredible scale. We are talking about safely consuming up to 50% or more of the user's free hard drive space. It's totally non-blocking, so your UI stays buttery smooth, and it handles everything asynchronously. This is exactly the kind of horsepower a heavy client-side app needs to actually thrive. Section 4, the streaming marriage. Now, knowing about IndexedDB is one thing, right? But how do we actually hook it up to a high-volume data pipe without just creating a different bottleneck? Well, following Margaret's blueprint, Timothy realizes he doesn't have to wait for the whole stream to finish before he saves it. As step 1 happens and those network chunks arrive, for step 2, he just bypasses local storage entirely. The cookie jar is out. For step 3, he marries the Streams API directly to an IndexedDB transaction. By using a modern promise-based utility, he can write those raw objects straight into the database the literal microsecond they drop out of the network pipe. Section 5, lightning-fast offline data. So, what happens when he wires this all up? It is honestly kind of magical. Timothy clears his cache, triggers the pipeline, and checks his application tab. He completely bypassed that 5 megabyte wall. Instead, he finds tens of thousands of raw records, fully indexed, just silently sitting there in the background, all without dropping a single frame of the UI. And the kicker? When he refreshes the page, the app instantly queries the local database. It doesn't even touch the network. Zero latency. The grid populates instantly. He just built a fully offline-capable client-side architecture. Absolutely brilliant. So as we wrap up this explainer, I really want you to take a hard look at your own architecture. Ask yourself, are you still treating your user's browser like a basic cookie jar, or are you finally ready to unlock the power of a production database? Stop artificially limiting your application's potential with outdated synchronous habits. The tools to build gigabyte-scale, offline-capable experiences are literally already sitting in the browser, waiting for you to use them. Thanks so much for joining me on this explainer, and keep building.